host for today's session. Few announcements before we begin. We aim to complete this webinar in 60 minutes, so please stay tuned with us. Please feel free to ask questions in the Q&A window during the course of the presentation, and your questions will be addressed at the end of the webinar by the speakers. This is an exclusive webinar, and we are happy to host eminent speakers from Locus Enterprise Solution and one of the key industry speakers as well. The uniqueness of the webinar today is that we have participants from the education industry and will be discussing on how cloud services put the world's most advanced computing capabilities within reach for more organizations, helping them to innovate faster and gain a competitive edge. We will discuss the advantages of running HPC workloads on Amazon Web Services, that is AWS. It gives me an immense pleasure in introducing our speakers for the day. We have Dr. Rajnikant Aluwala, the key industry speaker and a result-oriented leader and a team player with cross-functional experience of cloud computing, big data research, training, corporate communication, education management for more than 12 years. Dr. Rajnikant was heading the Department of Computer Science and Engineering. He's an effective communicator with exceptional presentation skills, abilities to lead cross-cultural teams handling training, corporate relations, cloud research forums, and has been a motivational speaker as well. Dr. Rajnikant, it's an absolute pleasure to have you today.
Thank you, ma'am. Thanks for the introduction.
We also have Alok with us. He is from Locus Enterprise Solution. Alok Pandey is a lead consultant with Locus Enterprise Solutions Limited. He carries over a decade plus years of experience in architecting, building a benchmark in high performance computing, clusters, analytics cluster, data lakes, and managing complex on-prem and cloud projects. He has consulted and delivered over 200 nodes to promise build petascale clusters at India and overseas. And apart from this, he has showcased his experience deploying data lakes on cloud, big data analytics clusters on-prem, on cloud, as well as designed vertical-based holistic and optimized solutions around AI. Alok, it's a pleasure to have you.
Thank you, Khushbu. Thank you very much. It was a nice introduction.
Awesome. So I would like to, hand it over to Dr. Rajnikant to start our session for today and address all our education industries leaders in this webinar.
Yeah, thank you, Khushbu ma'am, for making me a part of this particular webinar. And being an academician, working with students, academic projects, research projects, industry projects for over 17 years. And myself, having specialization in cloud computing, done my research on cloud computing, I believe in the high performance computing is the key for the computational science for the current day. As the academicians, as industry people, we all are seeing the complexity of the problems are growing. And to handle this particular complex problems, we are in need of high performance computing. When we just move a decade back in terms of academia to offer computer science engineering or information technology, when we go to any academic institution, what we could see is a computer lab, maybe i3, i5 processors. A computer lab is just sufficient enough to train the students, to offer the curriculum, and to make them industry ready. But we are able to see now the emerging technologies have come, emerging branches have come in engineering. Likewise, we are seeing BTech in artificial intelligence and machine learning, BTech in cloud computing, BTech in IoT, BTech in data science. So these emerging branches have come to make the graduates ready for the industry requirements, as the artificial intelligence is ruling the world now. And to develop applications and to run the applications using artificial technology, we are in need of high performance computing. As the academia is moving in line with the industry, the academia has to procure high performance computing infrastructure on campus. And this is on one dimension, training the students. The other side, academia works on research projects supported by Department of Science and Technology, AICTE, UGC, MIT, and various other funding agencies. And to work on the particular funding projects, to work on the complex problem statements, the researchers, the academia researchers are again in need of high performance computing infrastructure. So one side, just think of not having cloud computing services in place and procuring high performance computing infra in academic institutions, which are actually not for business, is going to be a big investment for the managements. The AWS services, which we are going to speak at the latter, is an advantage for the academia to carry on their research projects, to train the students on the cutting edge technologies, and to make them ready to work for the complex problems on which the industry is going to work. And the other side, the Indian education system started practicing outcome-based education. And every educational institution wants to become a true OBE practitioner. And to speak about becoming a true OBE practitioner, the educational institutions, the managements, the principal, heads, the teachers require the student data in hand. The real-time data is required on student learning, understanding what exactly the student is learning, understanding what exactly the student is performing, and the immediate, the relevant measures can be taken. So the educational institutions also are in need of the real-time data to understand and to adjust the scenarios to ensure that the higher learning takes place. So hence, the high performance computing infrastructure is much needed for an engineering institution or a higher educational institution to make their students ready for the industry and to ensure their researchers, their academia professors are working on the complex engineering problems such that the industry ready graduate is prepared. So with this short note, I end my talk over here. Thank you.
Great. Thank you so much, Dr. Rajnikant, for such wonderful insights. I would now like to invite Alok Pandey to take forward the discussion.
Thank you, Dr. Rajnikant, and thank you, Khushbu. So, very pleasant good morning, ladies and gentlemen, present today here. So, as Dr. Rajnikant said, that high performance computing has been key to solving the most complex problem in every industry. And it has been changing the way we work and live, right? Be it the invention of electricity 100 years ago, which changed our life, and industries after industry, then internet, right? That again changed our life, mobile, and high performance computing is behind those inventions and changes from in one or another form, right? But for too long, HPC applications and workloads have been constrained by limited on-premise infra capacity, which required higher capital investment and having constant needs for technology refresh. As Dr. Rajnikant told, right, you need to do upfront investment, build a facility on-premise, and then use it. And you are limited with the capacity you have augmented for a few years. So my talk today really revolves around showcasing how you can change your approach to build HPC system, which has been backbone for the many research on AWS cloud, which meet your current and future requirement without any upfront investment. So I am Alok Pandey, working as a principal consultant at Locus Enterprise Solutions Limited. Locus was founded in 2000, and since then, we are contributing in customer success in north, south, east, and west, and different part of globe. We are advanced consulting partner of AWS as well as having storage competency. We have over 70 cloud certified peoples who are helping our customers in HPC, cloud migration, data analytics, building storage and DR solutions on cloud, and ensuring required security and compliance in place for our customers' organization. We have deployed over 300 HPC clusters for various government and enterprise organizations, and few of them have been listed in top supercomputing list maintained by CDEC for our country. We are certified partner of many other OEMs like NVIDIA, Cisco, NSYS, Cloudera, Splunk, and so on. So we have around 150 plus customers, multiple deployments, and we have around 4 million man hours of experience and capability to build HPC of thousands of cores with the low latency of high speed interconnect and petabyte of storage, including parallel file system, archival, which is giving confidence to our customer that they are the correct domain partner. So as you know, right, HPC workload spans across machine learning, oil and gas discovery, right, genomics, life sciences, pharmaceutical, finance services, media, and so on and so forth. So although HPC applications share some common building blocks, they are not all similar, right? Few workload use huge CPU computation and works parallelly in many compute servers, and they are tightly coupled and require low latency and high bandwidth connectivity among compute servers. Whereas few applications, those needs to process high amount of data and require more memory in a single instance. And for certain kind of workload, we can assign many compute servers which are working in parallel on unique data set with separate instructions. So before we talk more about HPC on AWS, let me give you some confidence through showcasing some work we have done for our customers. So we have been part of some research organizations where we have deployed facility which help customers, right? Which help their customers and their users. So here are some examples, right? So one of the implementation of HPC, the research outcome, which helped eliminating blindness, which was caused by the gene mutation. There was a remote village in Andhra, but any child before achieving the age of 12, he was facing the blindness, complete blindness. So one research organization took initiative, worked on some genomes, DNAs, and did mutation on the HPC systems. We provided the required facility, we sized them for the required outcome, and they successfully designed and removed that problem from our country. And then we helped one of the organizations simulating weather model for fighter pilots so that they can take decisions when to land, when to fly. Right? We have been part of Moon mission Chandrayaan. We have helping organizations with the HPC setups who do accelerate in cancer research, and few enterprise organizations, like one organization which reduce the weight of farming machines so that the mileage can increase of the tractors, as well as the load and life spans a longer time. We have deployed the tsunami early warning systems for the country, and this is the deployment and how we have value added. This is one further thing, that optimization of the infrastructure. Deployment is one part, then optimization. So for example, weather forecasting, right? So weather forecasting, few of you might be from that background, right? That requires a lot of pre-processing, then running simulations, and then producing the result in graphical format. So we deployed the model, which was one-click solution. So once you give a single command, it will download the data from that in-car site. It will do all the 4 steps of pre-processing one by one, and then do the simulation run, and then create that image files. Second, for another customers, we have optimized the quantum espresso deployment with certain flags, compilation, and reduce the duration, which was running 24 hours to 18 hours. So if it is on-premise setup, right, this kind of optimization, if we are giving an on-premise, they can run various runs or various simulation with the available resources. When we are on the cloud, if we are reducing the run time, then we can save a lot of cost, because cloud is giving a lot of capability to scale the resources. So you can demand the resources as and when you need, but that becomes a cost. So when we are reducing the runtime, we are definitely reducing the cost on the cloud. And we have deployed Genomics in such a way, right? One of Genomics is one of the molecular dynamics application, so which was running 8-node CPUs earlier, and we have recompiled with the GPUs, help customer migrating certain part of code, so they could reduce the runtime from 3409 seconds to 277 seconds, from 8-node to 2-node. So a lot of infrastructure saving, a lot of time saving. So just give you the confidence that we have experience which is helping customers deploying the solution. So if I say how further Locus is differentiating with other partners who are building HPC. So we have, with this, working with the customers, right, 250 or 300 customers, we have deployed unique methodology, either to deploy clusters on premise or on the cloud, and the application optimization. And we are not only one domain specific. We help research organizations who are working on projects like IITs, ISS, so and IITs, other universities who are working on different projects. So one unit may be working on the healthcare project, maybe doing some scientific research, working with some pharma companies, and even pharma companies also. So academic institutes as well as industries, we are present. We know the various architectures, deployment, optimization, tuning. And with this experience, we have developed our tool also, Ganna, to provision on-premise cluster, as well as to submit the job on GUI basis, as well as integrating the on-premise to the cloud busting and deploying the cluster on the cloud with our tool and monitor that. So we have created container-based approach also, so that applications are containerized. It can run on-premise on any of the node without disturbing the others' environment, other users' environment, and quick deployment. As I said, that few of our deployment is listed in supercomputing list, which is maintained by CDAC. So those, we can say, the petaflop supercomputers we have built for our customers. So before we discuss AWS for HPC, I just would like to take you through why AWS first, right? Dr. Rajnikant said that there's certain things. Now I'll tell you, AWS provides highly reliable, scalable, and low-cost infrastructure, and around 190 countries, users and businesses from 190 countries are using AWS cloud, so that they are getting the infrastructure, global infrastructure, secured infrastructure, and they can go and scale as much as they need, with low cost, no upfront investment. So there are 7 factors, right, which sets AWS apart from other providers. Of course, AWS is a leader in the Gartner, right, for last 10 consecutive years. But other factors like security. So this is the responsibility of AWS, who maintain their infrastructure, as well as the responsibility of users and partners like Locus, who are users to write the secured application design architecture, and Locus helping to deploy the right policies, right compliance, so that everything is secured and only the permitted users can access the data. Then service pretend that I said 175 plus services, right? which is more than any other cloud providers that is provided by AWS. Then we talk about global footprint. 77 availability zones from 24 regions. I'll discuss regions a little more in the coming slides. Then machine learning. Very too many services available for required for machine learning, be it image processing, be it speech recognition, machine learning, SageMaker, a lot of things are available on the cloud. And then partner ecosystem like Locus. So there are special partners, like specialized partners who is competent, just like Locus in HPC, storage, cloud migration. So that is another thing AWS is having a great support from that industry's experienced organizations. And as I said, this is 10th consecutive year when AWS is leader in the Gartner's quadrant. So I said 24 regions earlier in my slide. So AWS Infra, just like we said, data centers, right? So AWS Infra is a global, which means the services are available to use by any subscriber without any restrictions across the world from these 24 high available data centers. And this is basics of AWS. I will not go too much in depth. Quickly help you. The new services are things which are basic blocks which are related to high performance computing clusters. So if I say, right, there are compute things. We need first thing compute. We need network. We need storage. These basic three things to build an HPC clusters, right? So we have general purpose instances, compute instances, GPU instances, GPU specific instances, graphics instances which can render 2D, 3D graphics to your system from the cloud. And we have a broadest choice of the processors, be it AWS, be it Intel processor, AMD processors, and AWS own processors, that is Graviton. Along with that, different kind of storage like block storage, object storage, shared file system, and parallel file system as a service. I'll quickly discuss a few important things on those topic. So I'll take you the first thing. You have been using AMD processors and Intel processors in your data center. Now AWS is coming with AWS Graviton's second generation of the processor, which is a ARM chip. That is coming from that is, you can say, designed and built by a company named Anpurna from Israel, which was acquired by AWS earlier. And so these instances also giving a lot of benefit in giving the performance, like 7x performance, 4x more compute cores, faster memory, right? And 64-bit this newer cores, 64 number of virtual CPUs with 20 gigabits of enhanced networking from one server to another server, and then 18 gigabits of bandwidth to the EBS. So there is EBS means block storage, just like your hard disk or your volumes attached from the SAN storage. Then there are basically three Graviton instances coming with the general purpose M series, and then compute intensive for HPC, big data, AI, and then memory intensive when we have SMP kind of services which require terabytes of memory for some threaded work. So we have infrastructure for that and on the cloud. Coming to the storage. So I just talked about the CPU, which is available in the form of EC2 instances, which is like VM, or you can say your server. Then we have a storage, three kind of storage. Block storage, just like your disks. Then you have file shares, that file storage, that is like NFS storage, mounting home directories to different servers, all right, together. So we have EFS, and then we have object storage, low cost object storage, where you can store your files and you can further archive in different tier or archival storage in the same S3 family for longer time at lower cost. This is very durable and highly available storage. Now I'm coming to file system, right? From storage, then we would need file systems. So you many of you must have used earlier the cluster file system, right? Cluster is a purpose-built, scalable, right? It is scalable to terabytes, terabytes to petabytes, single namespace, and open source, right? So it was earlier released in 2003, and since then it is very popularly used in the by the HPC community and users. So AWS is offering those services, but deploying before talking AWS. So even we need to build any HPC parallel file system using cluster, we need a lot of hardware and software. So few object storage, few metadata storage, few object storage servers, metadata servers, all those things providing this scalable and high throughput file system. So for that, you need to hire trained skilled personals, who will go and plan, size, and deploy and monitor and manage the file system. So AWS came with this idea and integrated this file system and put the name is Amazon FSx for Lustre file system. It is based on open source Lustre. It is fully managed and backend by AWS. What you need to just provision the space, how much capacity you want, and you need to install the Lustre client. If you are using Amazon Linux, the Lustre client is already inbuilt. Otherwise, it is supported with CentOS, Red Hat, SUSE Linux. All clients are available. So parallel file system, open source, earlier released in 2003, and since then being used and very popular. Most of the organizations are using. And entire data, right? Without our any efforts or any configuration, entire data at rest is secured and encrypted. So these are the basic building blocks. From here, I'll move to the pricing philosophy. Now we see that, okay, we are getting all these benefits. What is the cost for them? So many services on the cloud are pay for what you use based on demand. So suppose I have required 10 compute nodes for 15 days, I need to pay for 10 compute nodes for 15 days, or I need 200 compute nodes for 1 day, I need to pay for 200 node hours. So this is the way. And then second is the price reduction. If we see normal on-premise work, our graph goes up. So yesterday, if we deployed a facility, I need to invest X amount. Now another similar kind of nodes and processor, I need to pay X plus Y amount. But when we talk about the cloud, so once the service available, it becomes accessible to users. AWS is working as not as a much profitable organization. It is keep on reducing the price. So since 2006, they have reduced price about 85 times for different services. And there are 2-3 models, right? One is the on-demand, whatever you use, you pay. Second is the reserved instances. Reserved instances means for which I need a continuous utilization for next 1 year or 2 years or 3 years. We can go reduce the price doing a commitment that we are going to use for 3 years. Suppose master nodes or if we are building Lustre ourselves, then those Lustre nodes which will keep on running for years. So that is reserved instance. And then spot instances where price is reduced by 7 times in compared to on demand. Suppose I need to run my job for only 4 hours, right? Why to go for reserved instances or on demand? We can go and request AWS to get the free capacity, free pool resources from the existing infrastructure. So up to 8 hours, the spot instances are provided. But when AWS other customers need resources and free pool is not enough, then these spot instances are pulled back. So for lower workload, which are running 1 hour, 4 hours, or 6 hours, we can go with these spot instances and save the pricing. Now moving to HPC on AWS, right? As Professor Rajnikant said that you need to provision the infrastructure, build the capacity, and use that existing capacity for your cloud. You are bound to use the limited capacity in your premise. So, and it takes a lot of time to go write a specification, put in tender form, and get the infrastructure delivered and then deployed in your premise, optimized, and then access is released. But when we talk about AWS, this is instance access, right? Whatever resources we need, once we have an account which can be created in 2 to 3 days time, you will have access and you can build the infrastructure what you need immediately, no wait time. Now, there are 10 users, right? 10 users who are running on premise and accessing 4-node HPC cluster. 10 users were racing with each other, are competing for the resources as were kept in the long queues. So on the cloud, you have no wait time. We can, AWS provide the facility to scale the nodes. You can keep on adding. So running 8 servers for 8 days, right? And serving the different users in different queues. We can increase the 84 or 64 nodes and serve all, complete the task in a single day. So reducing the wait time as well as reducing the runtime. Flexible configuration, so you can scale up, scale down as and when you. And you need not to pay any upfront, right? Whatever I said, that whatever you are using, you are paying. And you are not worrying anything, whether AC is running, whether UPS is on, DG is there, people are there to switch on DG and fuel it when there is a power failure, right? You need not to worry anything. Researchers are just need to focus on their code, how they can optimize the code, how more models they can run, and how effective they can, how productive they can be, rather than spending time running behind IT or HPC administrator to get the infrastructure into use. So considering all the layers we have discussed and you must be knowing, so here is that one framework, HPC framework on AWS, what Locus helps in providing you from consulting, right? Sizing the infrastructure, building the, designing the cluster, network connectivity, data backup, security, planning the data recovery, so on and so forth, right? Till that deploying it, right? Hardware layer, BTC to instances with CPU, GPUs, right? On demand, reserved instances or spot instances with network capacity, right? 1 Gbps to 100 Gbps kind of networking is provided by AWS, and then storage, right? Storage EBS, right? EBS further have different kind of IOPS facility. So you can have SDDs, you can have SDDs, you can have NVMe disks, object storage, EFS, then parallel file system, right? Parallel file system or network file system, NFS. We help you in entire journey. Then we are helping you to deploy application along with the optimized environment. So be it MPIs, right? Intel MPI, just take you through one slide next to this. Then job scheduler, be it Altair, PBS Pro, open source, PBS Pro open source, AWS Batch, then Slum, and we help users to do all the job submission on the GUI mode with the help of Gunna. And we help users and organizations to keep the monitor and cost control with the entire workflow. So you need not to worry that next month you are going a huge bill. So as I said this, as we are Intel partners, so we do offer Intel deployment services and optimization services along with the cloud. So Intel One API HPC, which was parallel cluster earlier, so which provides MPI libraries, compilers, optimizers, tuners, advisors, so on and so forth. So we help users on-premise and on cloud specifically. So in the form of container or native deployment, so that users are getting the access and benefit of the entire life cycle from hardware to software with our partnership with ANSYS, Altair, and other ISPs. We understand the product and we optimize it for our users. And this is the cycle if I see how we are helping users. This is a complete workflow from determining the compute storage networking requirement and based on your HPC code or your application, we help you creating a dynamic cluster using AWS parallel cluster, then uh, module, and then which helps submitting HPC job, which allocate resources on demand on fly, either through GUI or through CLI, and then you can connect to your instances. You can see the live results using nice DCBs or Ganna console. And once the job is done, you can download the data back to your system, or you can keep it there. You can archive it on S3 storage for longer time at economical way. So these are the reference architecture which I'm going to talk now. So if I say manufacturing organizations who are using CFTC are the organizations doing research and designing, right? Few organizations which are working in earth science or designing some boilers or doing some engineering, designing some engineering products, or working on those applications with NCS, LS Dyna, Abacus, Star CCM. So we have complete workflow. We can utilize your existing on-premise licenses and connect you with the AWS direct connected dedicated link or through VPN, and provide the connectivity to organizations so that they can have low latency network or VPN connectivity, secure VPN connectivity. They can access servers or workstations on cloud for pre-processing, or they can do the pre-processing on their environment and only burst the right part of this compute, right? Only compute instances on cloud, or they can do complete life cycle on the cloud. One user, if you see here, one user, one cluster, another user, another cluster, they can scale on demand, or they can have a fixed budget. We can restrict utilization to consume that budget only. So 2 users or 3 users can put on wait. With a choice of file system, be it S3, EFS, FSX for Lustre. So entire pre-processing, simulation, post-processing, and visualization can be either completely on the cloud or can be a mixed environment. So you have workstations on your premise and can burst only for the compute to the cloud if you are out of space in the on-premise. So all those things we help for our we help to our users for the manufacturing as well as the education institutes who are doing all this research on these applications. Then EDA, we have different stacks for EDA. Different applications require different kind of infrastructure and different optimization. So just like in CFDC, we need pre-processing, meshing, simulation. So in EDA, right, we do block design, then verify design with compute intensive work, then design synthesis, verification, and then backend process, placement and routing, all verification, static time analysis, and then tape out to factory. So we help our customers to deploy the required compatible or optimized deployment of application on the right sized instances for different set of applications with different tools, right? Just like few tools need AWS Batch, few need setup can work with AWS parallel cluster, just scheduler like LSF or Slurm or PBS Pro. So we help our users, our customers with all skills. Then we talk about this finance, right? So finance is different requirement. So big data, just like HPC as well as this is a big data use cases, which require fraud detections, financial analysis, right? Doing financial analysis like market risk, credit risk, liquidity risks, then regulatory requirement, and then doing simulations with Monte Carlo or real-time simulations. So we help customers designing and deploying environment on the cloud with the right set of tools and with the right architecture. Further healthcare, right? So, genomics, right? You might be doing, some of you might be doing some research on genomics and life sciences, which workload use a massive amount of data points, right? Rather than they're working huge on data, terabytes or petabytes of data. So these workloads often require a share file system, a share file storage, which is accessed by large compute instances, and different applications again here in this domain need a different kind of computes. That some need batch processing, not compute intensive, but doing huge data processing. So we can containerize the application and put the complete workflow in serverless. So you need not to worry that where we are going to run with the help of Lambda, step functions, defining the workflow, and integrating with AWS batch. Your container can go and run anywhere and taking the input from S3 and storing output in S3 bucket. You need not to worry on the any infra provisioning at all. Then different set of applications which need shared memory resources. So where you can have higher instances, R series, and then C5 or M5, M6, C6 G instances, and then GPU intensive applications, GPU instances can be there. All those with the different kind of file systems. So if you have a smaller data set, you can go with EFS. If you need high IOPS, 100 gigabits plus IOPS, then you can go and use FSX for Luster. Then talk about energy domain, right? So again, different applications like Eclipse, Intersect, and Claritas. So most of them are compute intensive. So different kind of applications which are optimized for AMD, few instances which are optimized for Intel, and few needs Graviton, can get benefit of Graviton. So we help customers deploying all those optimized applications on the cloud. Then we have media, right? Media. So we see a lot of media stemming to our mobile phones systems. So media processing and transcoding workload, which includes video rendering, visual effects, and so on and so forth. So media processing workloads have different requirements. Some of the workloads require access to massive data set, and some are doing conversion, right, from one format to another. And remembering the state, if we are delivering one video, then we should be specific that what we should keep log of how much of this has been accessed. So complete stack, we are helping our customers to deploy the things which are species specific as well as for the user specific. So delivery is specific to users like rendering, as well as modeling and bringing animation and post production and doing motion tracking and motion management. So how do we help our customers, right? We help, as I said, we help right sizing, then deploying, optimizing, and post delivering the project. We help our customers doing SecOps. SecOps means we are going to monitor and manage your infrastructure up to the security and compliance level. Not only the monitoring the hardware health state, but up to the data, up to that state that where we continuously monitoring your data is secure, you are on right size instances, you are not overshooting to the budget, you are not over utilizing resources, or you're not under utilizing resources. So from novice to expert user, we have different kind of services which we are different kind of monitoring parameters, matrices with which we are helping our customers so that they can efficiently utilize the cloud resources, especially in HPC. Then we help customers, right? We help customers from the initial, right? From the sizing. So we go and work with end users, understand their requirement. Then we do analysis of their current and future requirement. Then we do this feasibility analysis, risk analysis, we do gap analysis, and then we create a high level target architecture. We get approval. We finish all this activity in 2 to 5 days based on the number of applications and number of features. Then we help our customers organization to board them to the cloud. So helping with the implementation plan, preparing and sharing the schedules, relying internal resources, and mapping with customers' organizational resources to work one-on-one or one-to-many so that the application is optimized and efficiently deployed on the cloud. Create a cloud account, uh, deploy the create the users on the cloud, IAM users, and deploy the right access policies so that only intended user or designated user can work the designated task. Then doing the performance optimizations, defining SLAs, success criteria, all those things. So this again for that 3 to 4 days activity. Uh, then we go and do the execution phase where we deploy the cluster, we do optimization, we do a benchmarking for application, for storage, right? And then configure the workflow where it automatically submitting the job once the data is available, or based on the user's policies or user's permission, they can scale up, scale down. All those limitations or facilities we help customers. And this activity is completed within 1 or 2 weeks based on the number of applications. And then after that, as in earlier site, we have discussed about HPC SecOps. We provide the sustenance services so that user are utilizing this is the continuous services. We take help of for our clouder. So with that, we are monitoring the utilization, doing cost optimization, doing right sizing, doing trade-offs also. Trade-off means you have subscribed for 1 tier of storage. And if you are not utilizing properly or you need different kind of storage to increase the performance, we keep on helping our customers with all those services. So just like this is sample discovery question for your reference here. Then we, okay. So this is the sample questions which we go and discuss initially, but this is, and even more based on their existing infrastructure and future requirement. As I said earlier, we are partner of many organizations. So we understand the on-premise infrastructure. We are listed, our deployments are listed in India's top supercomputing list. So we understand that how efficiently we need to design and deploy the solution to our organizations on-premise and on cloud. So before I discuss about our references, we are lack of time. So many organizations like IITs, ISIS, right? And IITs are our customers, and including DRDO and few other defense agencies. So due to restrictions, defense agencies are still on-premise, but a lot of educational institutes, enterprise organizations, they have already migrated to the cloud, and we are increasing our deployment to the cloud as nowadays. So if I summarize why HPC on cloud, right? So as you understood by now, that AWS HPC solutions removes the traditional challenges which are associated with the on-premise cluster, right? Like fixed infrastructure capacity or technology obsolescence. I have acquired one i3 processor today, right? Today, our Intel Xeon X family, and after 2 years, we are getting much higher cores in the same rack space, and which is consuming less power. So what my current infrastructure, this becomes a liability to us rather than usefulness. We are not competing to the world, right? With HPC, what we are doing, we are competing the world. We need to launch more product. We need to do complete the research faster. So when the newer technology is available to someone else, he's maybe running faster. So if I'm in a race, I have 800cc engine, right, in my car. I'm in the race and people are in 800, that's okay. This is my capacity, how trained driver am I? But when it becomes someone is coming with 2000cc to a 2-liter engine, definitely they will move faster. And how expert am I in the driving? I cannot compete with him. So that's technology, which is current technology with me after 2 years, that becomes a burden to me. On the cloud, there is nothing like this technology, but we can quickly shift from one processor, one storage class, one network type to another as soon as it is available to cloud, there is no limitation that I have to stick for certain period if I'm using on-demand or spot instances. If we are reserved instances or saving plans, we have option to go for a convertible reserved instances. In on-premise, we need to invest the amount upfront, so we say a high capital expenditure. But AWS, we get virtually unlimited HPC capacity in form of CPU, GPU, storage, right, network, and which is built on from the latest technologies. Now, you hardly see in the data centers, but in this AWS, you are getting that. So you can quickly migrate to newer, more powerful EC2 instances or compute cores as soon as they are available to AWS. You can remove the risk of on-premise CPU clusters becoming obsolete or underutilized or poor utilized. So as your needs changes over time. So AWS cloud on if I say security parts, many organizations who are doing some confidential research, they are worried about their data and information leak, right? So I would like to tell you here that AWS cloud, which is compliant with latest revisions of GDPR, HIPAA, FISMA, FedRAMP, PCI, and other regulations, different countries' regulations, because since this is a global infrastructure, so it is compliant to different countries' compliance policies. So encryptions, data encryption at rest, data encryption in transit, and granular permissions, right? With various other security services who are keep on putting your logs, who is accessing, what time the changes is being done, which part of the data has been accessed, what time, whether it is downloaded. So every log is maintained. So forensics are there properly deployed, and your ability to share data across group users. So all those things is provided by AWS. So simplified, flexible pricing structure. So allows research institutes like yours to create a scalable infrastructure, burden-free infrastructure, and within budget constraints, without any upfront investment on to build and monitor the data center. So we are running out of time now. So success story, we have quite a few I have depicted here, just like one for HPC and CFT workload. We have deployed for one of the customer which came with us for project requirement. So they could notice this is 3 times faster and faster than on-premise cluster, and was available within a week to run the job. For one of the EDA workflow, we have deployed the infrastructure, which is doing complete workflow from RTL design to tape out, and it could increase the performance by 22% and reduced utilize infrastructure so effectively that the license cost was reduced by 20% overall utilization. So this is one SMP case where in NemHands what we have deployed with one instance, right? 64 vCPUs and 97.6 GB memory, approximate 1 terabyte of memory with the AVX. So we proved them 14 times better performance than existing compilation on their hardware. So the compilation and move to different technology without any upfront investment give huge performance benefits. So you can see that the productivity is increased by 14 times, which is not easy, right? So with this, I'll take a pause here. I'm ready to take questions if you have. I'm Alok Pandey, working as a principal consultant at Locus Enterprise Solutions Limited, which is serving our hugest community, especially in HPC, for last almost 2 decades now. Okay, thank you. You have been very present and you stayed throughout the session. So I I assume and I wish that session is useful to you, and you can think of being more productive using or migrating your HPC workload on cloud. Thank you once again. And if any questions are there, I can take it.
Alok, I can see a few questions. I'm just going to read out them to you. So the first
Okay.
question that I see is whether Rocky Linux will support Lustre file system.
So Linux Rocky, when we talk about FSX for Lustre, so we need not to worry the backend protocol. Each and everything is managed by AWS. So this is AWS managed services. We need a Lustre client, which works on converts Ethernet. Yes. So when AWS provides 100 gig Ethernet connectivity with over EFA, so it supports, and even you can install those clients in your on-premise, and you can get the benefit of, you can write the data to the cloud, but it depends on the internet bandwidth.
Got it. The next question is, how about specific hardware for courses to be deployed and connectivity for students?
Okay, so see, students, if they are just going to learn the parallel programming, they need Intel One API, that is parallel programming application interface, and then they would need the multiple cores where they can go and run those code on the parallel in parallel. So 4x large instances can be useful, and sometimes just for testing purpose at users lab, we can go with the very low cost T5 instances for the cloud.
Got it. We actually neck on time, but I'm just going to take one or two more questions, and so I'll read out them for you. Whether the AWS HPC cluster supports standard MPI programs to work on few hundreds of nodes.
Yes, if your code is scaling on premise, definitely the same code will go and scale to the cloud. It completely depends on the code or application, which the scalability depends on the code and application and the data you are using for that. So standard MPI, if it's scalable, yes, definitely it will scale. If you need certain changes or you need a better utilization, you can move to some commercial MPIs like Intel's or AMD's.
One more last. What minimum network speed is required? In the brackets, it's written data I/O in our premises for HPC or AWS.
Correct. So as I said, that different users have different kind of application. Some applications which are running a smaller data set, but doing a lot of computations. So if I say file is 2 GB only, just like with, let's say with a simulation. So input file may be 2 GB, but intermediate data, it may be generating around 50 GB and then output in 50 MB. The same way if we are running CFD applications. So initial application has smaller file and output may be bigger file. So it completely depends on the data input size, how fast you want to upload to the cloud, because you need to upload to the cloud first before running. So there are various technologies available to boost up to accelerate the upload. So if I say we have a 2 GB file input, then 40 Mbps, my broadband network is sufficient to upload that file to the cloud. Or if we have ILL, it may be 8 Mbps or 10 Mbps, that should be sufficient to start with. But if we have huge data, right, then gigabits of link are available in the market for institutes and other enterprise organizations, so they can be utilized.
Got it. Okay, so there's one more. What about combined CPU and GPU benchmark?
Yes. So we have tested various applications, Gromax and other Gromax is open source and other commercial applications. When we do that utilization in the cloud, be it CPU or be it GPU. So we have tested many applications for many organizations. We have provided at per performance or even better performance than on-premise on the cloud. So be it CPU alone or be it CPU with GPU. We have numbers. So if you need something, you can write to me at alok.pandey@locus.com. We can discuss a specific use case and we can share those numbers.
Awesome. Great. I think this was a wonderful session, and thank you, Alok. Thank you, Dr. Rajnikant, for taking out time and being our speakers for today's session. Thank you to all the participants who've joined us today, and it was a great pleasure to host you all. Please feel free to reach out to us for any further questions. We'll take them offline and we'll reach out to you for sure. We'll share the recording of this webinar over an email, and we look forward to having you in our subsequent webinars. Thank you.
Thank you. Thank you very much, everyone, for joining the session. Thank you, Professor Rajnikant.
Thank you.